Hello everyone, welcome to Pre-Algebra with Miss Betsy. We're going to be continuing our discussion this week of integers. Today we are specifically going to be discussing how we add integers together. And you'll remember that integers are composed of the whole numbers and their opposites. This is the text that I'm using. It's Pre-Algebra for Christian Schools, published by Bob Jones University Press. I'm using the first edition. Second edition, the order of the topics varies somewhat, but you can still learn how to add integers by watching this video, regardless of if you're using a BJU Press book or some other textbook. So let's go ahead and pray, and I've got a lame joke for you, and we'll see what we have to do. Father, I thank you that you are alive and well and that you still speak to us today. Father, I ask that you would give us ears to hear you and that you would give us the ability and the willingness to study and to learn the material that you place before us. Father, help us to honor you in all that we do, and I pray in the name of your Son, Jesus. Amen. Okay, this week, as I'm going to actually look at my text on video camera. See, isn't that good? And it was a totally inconsequential text. So, this week the jokes are going to have to do with chickens. But the first one is not a chicken crossing the road. It's the question that I'd like to ask you is, why do hens lay eggs? Well, the reason they lay eggs is that if they dropped those eggs, they would break, so they lay them down. Okay, section 4.2 is adding integers. And I said just a moment ago that integers are composed of the whole numbers and their opposites. And if we were to write the whole numbers on a number line, we would only begin with 0. The pattern that we would use would be 0, 1, 2, 3, 4, and so on forever. And then we said that the integers has these whole numbers plus their opposites. And earlier we learned that opposites are the same distance from 0, but in a different direction on the number line. So let me put some opposites in here. If I look at a positive 1, that's 1 unit from 0 to the right. Its opposite, which is a negative 1, is 1 unit from 0 to the left. If I look at negative 3, right here, negative 3 is 3 units from 0 to the left. Its opposite is going to be the same distance from 0 in the opposite direction. And look at that. 3 units from 0 to the right is a positive 3. So a working understanding of what opposites are is you have a number and you make it negative. If you have a negative number, you change the sign and it's positive. The opposite of a negative 3 is a positive 3. The opposite of 100,021 is a negative 100,021. Whoops. 100,021. So opposites in our minds, the numbers look exactly the same, but one of them is positive, and we don't show that positive sign. One of them is negative. And this is going to be important, understanding opposites and understanding negatives, when we add numbers together. So, if we have this number line that I've just erased, and we are talking about pairs of numbers, what possible combinations of pairs of numbers can we have? Well, what if we said 4 plus 5, and then we said negative 4 plus a negative 5, and then we said negative 4 plus a positive 5. And you see that I've used the same digits in all three problems, but the signs in front of the digits have changed. We have a negative 4, positive 5. We have two negatives, we have two positives. These are the only possible combinations of numbers that you can have when you are adding integers. You have two numbers that are positive that you're adding. You have two numbers that are negative that you are adding. Or you have two numbers that you add together that have opposite signs. Now, I'm not going to track real closely with the text today because they really go into a needful theoretical explanation of how you add integers, but it can tend to get you really confused. So I'm just going to sort of put together a working definition lecture here and make all of the math teachers in the world not particularly pleased at me, but I think this will help you. I do want to illustrate at first the addition of numbers on the number line, and I'm going to keep this just like I have here, which means I need to make a longer number line. I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you'll bear with me just for a moment, I'm going to get my numbers on this number line, and then I'm going to have the opposites 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5, 6, 7, 8, 9. And just like we don't count on our fingers when we add, when we're in pre-algebra, we're not going to add integers on a number line by drawing pictures, but we are going to do it just for a moment to illustrate what you're doing. When you're adding numbers together, you can use your number line as a visual aid by starting at 0. Start at 0. Positive to the right. Positive goes to the right. And negative will go to the left. So let's look and see what happens. 4 plus 5, everyone knows that a positive 4 and a positive 5 are 9. So I'm going to use blue for positive, and I'm going to use red for negative. I'm going to illustrate these three addition problems here for you. We're going to start at 0, and it says go 4 units to the right. 1, 2, 3, 4. So this right here, we don't have a plus sign that you can see in front of the 4, but you know that's a 4. So we're going to start at 0. We go 4 units to the right. Now what does it say to do? It says we're going to add 5 or go 5 more units to the right. So we go from 4 to 5 is 1, 2, 3, 4. When we get 5 more units to the right, we have traveled 5 units in the positive direction on the number, and amazing, 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 we have ended up at number 9, which of course is the solution to 4 plus 5. When you add a positive number, 4, and a positive 5 together, you end up with a positive 9. Now, what's going to happen if we add negative numbers? Let's see. Instead, I'm going to use the red to indicate a negative number. So here that says we're going to start at 0 and we're going to have a negative 4. So we're going to move 4 units, 1, 2, 3, 4, in the negative direction. So we have gone negative 4 units from 0, and of course we are at negative 4 in the number line. Now, Don't even think about, don't say plus is, what am I going to do with plus? Think about, well, we've already gone 4 units to the left, negative. Now they want us to go from where we are 5 more units to the left because it's negative. So we go 1, 2, 3, 4, 5. We end up here. And we have gone a negative 5, and look at where we're at. We are at negative 9. So you can see that even if you're not familiar at all with adding signed numbers together, you see there's some sort of connection. 4 and 5 is the 9 that you know. 4 and 5, of course, is 9, but it's negative. Now, let's see what happens when we have different signs. And I'm going to illustrate that down here below. We have a negative 4. We already know it's going to look like this. 1, 2, 3, 4 units from 0 in the negative direction. And now what are we going to do? Well, it says plus 5. It's a positive number, correct? Positive numbers move to the right. So we ended up here. Now we're going to move 5 units to the right. 1, 2, 3, 4, 5. And that stopping point right there is what happens when we add a negative 4 and a positive 5 together. You end up with a 1, with a positive 1. Now, let's go back and look at this. Positive 4 and positive 5 is a 9. See a connection here? 2 positives. And your answer is positive. Let's look here. Negative 9. You have 2 negative numbers that you're adding together. And your number is negative 9. Now we get over to this mess. Okay, one number's positive, one number's negative. We ended up with a positive answer, and it's a 1. What can you see here? See a relationship between numbers? Yes. 5 minus 4 is 1, isn't it? And which is the bigger number? Is it the negative 4? If you ignore the sign, rather, don't pay any attention to the negative, is the 4 or the 5 larger? 5 is larger than 4. And they took that sign, which is a positive. And this is the connection. When you're adding signed numbers together, if the signs are the same, add the digits and use the sign. The signs are the same, you add 4 plus 5, and you use the positive sign to get a positive 9. Here, the signs are different. So you add 4 and 5 together, and you keep the sign, which is a negative 9. Here, the signs are different. One is negative, one is positive. You subtract the number that looks smaller from the larger number. 5 minus 4 is 1, and you use the sign of the number that's bigger. So this is a positive 1. Now the reason you're allowed to do this has to do with the absolute value of numbers, and that's what the rules are that they talk about in your book. And let me illustrate that for you just real quickly, because obviously if the further to the left a number is on the number line determines the smaller number. And that's going to be an important thing to help us make certain that we understand that the further to left a number is on the number line, the smaller it is. Like a negative 100 is much smaller than a positive 2, because the negative 100 is way over here. Positive 2 is only just a little bit to the right of 0. But this misunderstanding here, which I expect probably none of you are having difficulty with that, but it has to do with way back when we were teeny tiny, and we were much happier if we had 6 pennies than if we had a quarter, because we had more things in our hand. And we didn't realize the value of the pennies was much less than the value of the quarter. Same thing here, when you're first starting off, we just key into the fact that you know 100 is bigger than 2, but you don't understand that this negative sign makes it much, much, much smaller. Okay. Let me talk about this absolute value just by doing problems. 2 different types. We have positive plus positive. We have negative plus negative. And they say, add the absolute, and I'm going to read this to you. This is on page 116. Adding integers with like signs. Add the absolute value of the addends, write the sign of the addends in the sum. Okay, if you have 6 plus 7, nobody needs to be taught that 6 plus 7 is 13. But using their rule, we would take the absolute value of 6 plus the absolute value of 7. And remember, absolute value is the distance from 0 on the number line. We talked about the distance from 0 again at the beginning of this lecture. What's the absolute value of 6? Well, it's 6. Absolute value of 7 is 7. And you end up with 13 as your answer. But of course, when you're adding positive numbers, you don't need that help because you know how to add positive numbers. However, when you're adding negative numbers, until you are accustomed to what you're doing, you might need some help. And this is the basis for adding integers together. You take the absolute value of a negative 6 plus the absolute value of a negative 7, which is 6 plus 7, which is 13. And then your book says, write the sign of the addends in the sum. What are we adding together here? The sign of these addends. Remember, addends are the 2 different numbers, 2 different quantities that you're adding together. The signs here are negative, so you use that sign in the sum. And this is what I mean when I use the technically incorrect description to say, as long as your signs of your numbers are the same, add the numbers, use the sign. 6 plus 7, it's positive. Negative 6 plus a negative 7, just think about adding 6 and 7. You get 13. Because both of those numbers are negative, it's a negative 13. Now, what are you going to do when you have differing signs? When one is positive and one is negative? And this is what I illustrated for you with negative 4 plus 5. And we came up with a positive 1 as our answer. Remember that? Well, the rule for this says on page 117, find the difference of the absolute values of the addends. Write the sign of the integer with the greater absolute value in the sum. And you may have just zoned out on me with all of those words. This is what they're saying to do. We want to find the absolute value of both of these integers, but we're going to find the difference, which is a subtraction problem. So it means we want to put the bigger looking number in the first. We're going to say the absolute value of 5 minus the absolute value of a negative 4. Absolute value of 5 is 5 minus the absolute value of negative 4 is 4. 5 minus 4 is 1. The second part says, write the sign of the integer with the greater absolute value in the sum. This is the integer that has the greater absolute value. It's 5. That's positive, and that's how we end up with a positive 1. If we had done this differently, if this had been a positive 4 plus a negative 5. We're still going to set it up this way, but we're going to have the absolute value of a negative 5 minus the absolute value of 4. You have 5 minus 4. But it says use the sign of the number with the greater absolute value, which is where you end up with this negative 1. So see that I really can't help myself trying to teach some of the theoretical basis for that. What this means, all technicalities being ignored, is subtract the number that looks like the smaller one from the larger one. 5 minus 4 is 1. And use the sign that's sitting close to the bigger number, negative 1. Let me show you what I'm talking about by quickly going through these problems in our skill check. Oh, before we do that, on page 118, they talk about the opposites property of addition. Before we do this, let's take a different pen that has more ink in it. So we have a negative 8 plus 3. These are oppositely signed numbers, so you're going to subtract the smaller looking number from the larger one. It's 5, but you're going to remember that the sign of the number with the larger absolute value, or the sign of the number that looks bigger, was negative. So, negative 8 plus 3 is a negative 5. Excuse me. Now, if we had 8 plus a negative 3, we're going to ignore the signs and subtract the numbers. 8 minus 3 is 5, but we're going to go back and look up at the original problem and see that the sign of the number that looks to our minds, when we ignore the signs as being larger, is a positive. So negative 8 plus 3 is a negative 5. 8 plus a negative 3 is a positive 5. But what happens if we have negative 8 plus 8? We're going to subtract the numbers and we're going to get 0. But what sign are we going to use? There is no sign. 0 is neither positive nor negative. Neither positive nor negative. So the opposites property of addition, and you have to know this, the opposites property of addition tells you that if you add a number and its opposite together, their sum will always be 0. Opposites property of addition. A number and its opposite is always going to be equal to 0. In algebraic notation, this says A plus the opposite of A is 0. The opposite of A plus A is 0. There's no sign involved because 0 is neither positive nor negative. Now, let's go ahead and look real quick. We're going to do all 10 of these skill checks so fast you will think, wow, Mom, this was really easy. We have negative 17 plus a negative 4. Are these signs the same? The signs are the same, so you're going to add the integers. Add the 17 and the 4 together, which is 21, and you're going to use the sign. Negative 17 plus negative 4 is a negative 21. And look at a number line in your head. You start at 0, you go 4 units to the left, 17 units more to the left. You're clearly at negative 21. Problem number 2, 16 plus 19 is 35. And it's a positive 35, because these are the same signs on these integers, so you keep the sign when you add them. Problem number 3, we have a negative 22 plus a negative 18. Now for some of you who might want to see where you're actually using those absolute value bars, we're going to find the absolute value of both of these numbers. Absolute value of negative 18. We have 22 plus 18, and I can't add today. We have 40, but we're going to use the sign that they have in common, which is a negative 40. Everyone with me? We have number 4 of our skill check. Negative 6 plus the opposite of 2, or plus a negative 2. The signs are the same. You add the numbers. Keep the sign. Add the numbers. Keep the sign. Not technically correct, but I think probably meaningful to you. The signs are the same. 17 plus 4, negative 21, you keep the sign. The signs are the same. Add 16 and 19, they're both positive, you keep the positive. Here, 22, 18, the signs are the same. You add 22 and 18, you get 40. Because you're adding two negatives, both those signs are negatives, your sum is going to be negative as well. Number 5, 13 plus the opposite of 5. Oppositely signed numbers, when you add them, subtract the smaller looking number from the larger looking number, ignoring the signs. 13 plus the opposite of 5, 13 minus 5 is 8. We look at the sign in front of the larger number. Now to speak this technically correct, what we would do is we would subtract their absolute values. What's the absolute value of 13? It's 13. What's the absolute value of a negative 5? It's 5. 13 minus 5 is 8. And we're going to use the sign of the number in the original problem that has the larger absolute value. 13 had the larger absolute value, so that's why our answer is 8. Okay, pretty straightforward. Now, let's go ahead and look at, I'm not going to do number 6. Find the missing integer. Negative 8 plus a is equal to 0. This is number 7. And here they're using the opposite property. It says a number and its opposite is always equal to 0. What's the opposite of a negative 8? Negative 8's here. What's its opposite on the number line? A positive 8. So a is equal to 8. Problem number 7, 2 plus the opposite of 2, or a negative 2, is equal to b. What's that answer going to be? A number and its opposite is always equal to 0. So b is equal to 0. Now we have two problems where we are going to evaluate, and this will be very, very easy for you, I believe. Evaluate. N, this is number 9, n plus 6, 4, n equals negative 13. Okay, and my kids in my co-op, show your substitution. What value do you have for n? You have a negative 13. So that becomes negative 13 plus 6. Those signs are opposites, you're going to subtract. 13 minus 6 is 7. And you use the sign of the number with the larger absolute value. you have a negative 7. And the final example in our skill check is problem 10, and it says evaluate m plus the opposite of 8 for m equals a negative 9. Show your substitution for me. Negative 9 plus a negative 8. You can say negative 8 or the opposite of 8. Notice that the signs here are the same. 9 plus 8 is 17. The signs are the same. They're both negative, so that sum is a negative 17. And if you were using the technically correct way in the book, you would find the absolute value. This is what that would look like. You would have the absolute value of negative 9, plus the absolute value of a negative 8. You know that absolute value is always positive because it's the distance from 0. So you have a 9 plus 8 gives you 17. Now you need to determine the sign in front of the 17. Because both of those digits were negative addends, you're going to use that negative sign. That's all that there is to section 4.2. Should not have any difficulty with it, but if you do, send me a text or ask me a question in class, and I'll see you next time.